These two dots above the 7 and the 2, these mean reoccurring. So this number is actually 0.572727272 on forever and ever. So what I'm going to do is I'm going to call this recurring decimal 0.572 as the equivalent of a number x. Okay, and what I'm going to try and do is get the decimal point to the start of the repetition and to the end of the repetition. What I mean by that is if I time this x by 10, then I times the other side by 10 as well. I'm going to get to 5.72 reoccurring. So what I think I've got to the beginning of the repetition. Now if I multiply both sides again by 100, I'm going to get to the end of the repetition. So 10 times by 100 is going to be 1000x, and that's going to equal 572.72727272. Okay, and now I see that I've got the same horrible ending on 1000x and 10x. So if I do 1000x take away 10x, I'm going to get a nice round number. And so let's do that. If you think, why am I doing that? I'm trying to get rid of this horrible 727272 ending. And so what is 1000x? 1000x is 572.72 reoccurring. And what is 10x? Well, 10x is 5.727272 reoccurring. And so now if I take one away from the other, you see that horrible endings that go away? I'm left with 567, which tells me that 990x is the same thing as 567. Well, that's brilliant, because now I can divide both sides by 990 to get x by itself. And remember, x is the same as the question we started off with, 0.5727272, etc. So all I need to do now is use my calculator to simplify that fraction. It certainly looks like 3 is going to go in top and bottom for sure, but maybe 9 does as well. So 567 over 990, the calculator that's 63 over 110. And that's exactly what they wanted. So I'm going to write down that therefore x is equal to 63 over 110 as required. Okay, and the next part of the question we got is also a bit of algebra, and this time we are rationalising the denominator. Now to do that, we have to multiply top and bottom of this first fraction by its conjugate. It's a strange word, isn't it? Conjugate, and what that means is 2 plus root y, and I'll show you why that works. Okay, so I'm going to multiply this fraction, this horrible looking fraction. I'm going to multiply it by its conjugate. Now, of course, I can't change the question, so I can only multiply this fraction by 1, or the equivalent of 1. So the only way I can get around that is if I multiply both the top and the bottom by its conjugate, 2 plus root y. 2 plus root y. Do you see this fraction I just created? It's the same as 1, isn't it? And so it's okay multiplying anything by 1, it doesn't change the question. So I'm allowed to do this, and even better than that, when I come to multiply the numerator and the denominator, something nice is going to happen in the denominator. We're going to rationalise it, we're going to have no square roots. So up in the numerator, I'm doing 3 times the top over the bottom two numbers, the conjugates, the conjugate pair. And I need to do now is just simplify this out. So 3 times by 2 is 6, 3 times by root y is 3 root y. And now look at the denominator. You could do FOIL, but we only need FL. So FOIL. So 2 times by 2 is 4. We've got plus 2 root y, take away 2 root y, disappears, and we're left with minus y. And in actual fact, we've got exactly what we wanted. So a is equal to 6, b is equal to 3, and c is equal to 4. And that is that question done. So let's go and have a little look at the examiner's report and see what went wrong there. Well, not much actually. So people new to multiply, it's just a question of don't muck it up when you're multiplying out when you multiply by top and bottom by 2 plus root y. Root y times by root y equals y. Okay, and of course the middle two terms are going to disappear off the FOIL, so it's more like fl. And what about part A? Did we get that one? Yes, we did. We did the same method as the examiner suggests.